Center internship talk will be by Kailey Pierce. Are you there, Kailey?
Yeah, I'm here.
So you want to set this up, John? You spotlight Kailey or her slides?
Okay. Can you see my slides okay?
Yes, we can. Go ahead.
Do you have a camera you want to use?
I actually don't have a camera. Is that all right?
Yeah, that's fine. But right now we're seeing presentation view, not single slide view.
Okay. Single slide is on my other computer. Yeah, it's putting the presentation over here. Oh my gosh. Sorry, I have dual monitors on, so it's putting the presentation on the other monitor.
Right. Happens if you go to the bottom and just click on the icon on the bottom right.
All right.
Setup slideshow.
But
If you
also,
hit the setup slideshow,
Pick-
you can choose which monitor to.
yeah, pick specific monitor.
Oh, here we go. Can you
All
see
right.
it now?
Yes, go ahead.
All right, great. So my name is Kailey Pierce. I am a current senior studying aerospace engineering mechanics here at the university. I participated in the NASA Academy at Langley Research Center last summer. The program ranged from, or was a 10-week program that went from June to August last year. So here's a little bit of my presentation outline. So I'm going to give a brief team breakdown and talk a little bit about my internship experience. Then I'll go through the project description, show you a project overview for the data acquisition group, and then open it up for questions and feedback. So here's a little bit of a team breakdown. There were 21 members, and within those 21 members, we represented about 10 universities. Most of us were undergrad students. However, there were a few graduate students and recent graduates involved. Our format was 5 weeks of a virtual internship. So we, like Walker said, we got our NASA computers and used those to communicate from home. And then we spent 5 weeks together at a hotel in Virginia. But even though we were in Virginia, we weren't going on center every day. We were just at the hotel collaborating there. It was still really great to be able to collaborate because we were from all over the US. So it was more difficult working from home because we represented like 3 different time zones. So we had to maneuver our working hours around people's like wake up times based on where they were. But we did get 2 visits to Langley Research Center, and we did take a visit to the Air Force Base. We got the amazing experience of looking at an F-22 up close and getting an overview from a colonel at the Air Force Base. Here's our project description for last year. Our mission was to look at existing NASA technologies and potentially create some of our own technologies if we developed areas of need to solve some important wildfire management issues. So we identified through the NASA ARMD Wildfire Management Conference last year that there's a huge need for real-time data collection and better communication amongst wildfire officials. So there's often multiple different organizations working at incident sites, and there can be some lack of communication there. They also mentioned that usually wildfire incidents use call when needed drones. So sometimes they're only getting 1 or 2 pictures of a wildfire per day. And by the time that they have the data, the situation has changed. So it is not as useful as they would like. We also determined that there's a need for better communication between civilians and emergency services to speed up evacuation and also for wildfire siting. Finally, we determined that equipment for firefighters on the ground could be a lot better than it is. We determined that fire shelters could have some improvements as well as there's not really a proper respirator that wildland firefighters have. They usually just use shrouds. So we determined that we could really help them out by looking into those areas. So we split into the three groups, data acquisition group, a communications group, and an equipment development group. Today I'm going to be presenting entirely on the data acquisition group because the information from the equipment development group and the communications group is still being used for projects. So some of that cannot be shared. So initially, when we started the data acquisition group, we had to pick between whether we wanted to look into sensors and GPS data for firefighters or look into a flight system to get some atmospheric data, as well as maps of how the fire is moving. We determined that through our collective skill sets, most of us were studying aerospace and mechanical engineering. So we determined that a flight system probably would fall more within our skill set and decided to pursue that as our group mission. So we started out with a UAV trade study. We made a spreadsheet full of around 100 UAVs, and we set ourselves some screening benchmarks. So we talked to a couple local fire departments, as well as some other organizations, and we determined that they would value a system at this like under $2,000. So we set, or $200,000. So we set that as our price limit. We also determined like preliminarily what sensors we would like to use and like what type of payload we're looking at. And we decided 3-hour endurance was important because we wanted to make sure that we could go out and get data before the situations changed too much to where that data would not be useful anymore. We also looked into wind resistance, and that is where we got the idea of using a rotorcraft over a VTOL or a fixed wing. So we wanted something that was going to be very stable when taking photos, and that overall is how we ended up with the Skyfront Perimeter 8 as our selection. So we decided to move forward with the Skyfront Perimeter 8 as the ideal UAV that the system would utilize. After we determined our UAV, we kind of split up into sections, looking into data logistics, how our data is being used, and cycling that through to get to the flight computer. We also had a group looking at the payload and what type of sensors would be used. We developed a mission plan as well as a budget. There were several restrictions in incident airspace. Incident airspace is very, very complicated because there's multiple organizations firefighting. And at the current moment, firefighters and air traffic controllers in those situations don't really want UAVs crowding incident airspace. There's not like a lot of regulations for how UAVs are allowed to fly over incidents at the current moment, or at least they're not like released to the public. But NASA Stereo is working to combat the problem of integrating manned and unmanned traffic over emergency airspace. So what the Stereo program is doing is they've created a software that unmanned systems can use, which if an unmanned system is flying at a certain height and a manned aircraft enters into that airspace, it will push the unmanned aircraft down a level or force it to land. So we think that when this project comes to fruition, it's going to make having UAVs like this in incident airspace much more possible and a more welcome present. Another issue that we faced was operation over human beings. Unfortunately, the UAV we selected, if it were to crash or something, it's not going to be Rule 107 compliant because of its size. Overall, because of the instability over wildfire incidents, it was important to make sure that our mission meant we were avoiding operation over people and vehicles as much as possible. However, we did talk about possibly utilizing a parachute to mitigate risks in the event of a failure. And then two other things worth mentioning are beyond the line of sight and operation at night. Those were important to make sure. Those were important factors when considering what sensors we were going to use. And then with all that being considered, we developed two mission plans for the system. So before manned aircraft enter the airspace, we would like to fly at around 1,000 to 15 feet, hovering and taking large pictures of the fire. But then when manned aircraft enter, we can drop down to 4,000 feet and cruise along the fire lines, kind of mapping out where the fire lines are. Another mission plan that's separate from this is after the wildfire has burned over and fire crews are cleaning up, there's hot spots that continue burning underneath the ground. At the current moment, firefighters have to crawl around on their hands and knees and just kind of dig around and feel for them. But you can actually sense them with an IR camera. So we feel that this system would be great for that use as well. And then here was the final payload sensor selection. As determined before, or as mentioned before, we're going to be using an IR sensor. We decided that the IR sensor will point directly downward as opposed to an angle because it was easier to not have to run the conversions for the angle when we're in our image processing software. We're also going to have a digital camera mounted for extra visual confirmation whilst we're in the air. And then another important thing was to have the anemometer as well as the humidity, temperature, and pressure sensors. It was really important for firefighters to get that atmospheric data during a fire to predict the next. What was that?
John, can you mute Elmo, please?
Can I mute?
No, keep going, Kailey.
Okay, thank you. Here is our Payload Cad integration. So unfortunately, it seems that the underneath the cover of the UAV is proprietary. So we kind of took a black box approach when mounting. I learned this morning that the GIF is actually broken, so you're not going to see anything here. But on the upper mount, we mounted the anemometer. The problem with that was it had to be 21 centimeters away from the base. So I designed this fun rod mount to put the anemometer and the transponder on. And then the lower mount will just be mounted directly to the base, and it'll have the IR sensor facing downward, the 2-axis gimbal, optical camera, PHT sensor, and the Raspberry Pi. And then here is the upper mount. So you can see it has the anemometer as well as the ruggedized transponder. It was very important to make sure that everything is ruggedized because of the presence of smoke in the atmosphere. And then here you can see the digital camera is mounted at an angle and the IR sensor is mounted downwards. And again, the Raspberry Pi is encased in a ruggedized case. Then here is our budget. As you can see, all of the sensors end up totaling around $8,000. Other important costs were maintenance kits. We anticipate this is going to require a lot of maintenance due to the presence of smoke and interesting atmospheric conditions. We're also unsure about insurance and piloting costs at this time. Then here is a block diagram for the data logistics. As you can see, it takes the GPS, barometer, and magnetometer data, as well as the webcam data, and then transfers that to the ground via Wi-Fi hotspot. So finally talking about future work, we did get one test of the imaging software that we developed on center. However, we ran out of time and we were not able to perform more tests on that. So we would like to do a lot more testing with a full-scale equivalent with the complete sensor suite integrated. And once we get the image software to the quality that we would like, we feel that this could have fully autonomous functionality, and we can utilize the system to autonomously map fire lines. We would also like to improve data transmission scheme because that was why our test ended up failing at that time. Yeah, I think my presentation ran a little quick, but does anyone have any questions?
Let's give her a hand.
Thank you.
So I'm going to start with a question, and that is the data from this vehicle supposed to reach the ground operators in real time, or you have to land the vehicle and extract the data?
We'd like to get the data to the ground in real time.
Kailey? Dylan?
So can you say again what the logic was for going with a rotorcraft as opposed to a fixed wing airplane?
We talked a lot about like the stability of images, like when we're flying that high up, and we talked about the speed and the range of the aircraft. And sorry, it's been like 6 months since I had this conversation last, so it's not fresh in my brain. But I think the reason for choosing a rotorcraft over a fixed wing or a VTOL was because of the stability of images and also the pricing of it.
Okay. All right, I mean, I buy that. Okay.
Is it also related to the difficulty of launching it, just because you might be operating in forested areas and stuff like that and recovering it?
Yes, that was another thing. And we also wanted it to be able to fit in the back of an SUV. So that was another factor. Does David have a question?
Yeah, I have a quick question. Were you able to test at all how the rotors are able to function correctly in the smoke, or how the smoke would affect the controllability of the craft?
We did not have the opportunity to test that. We were only able to fly it in the flight cage under normal conditions when we did our tests. So unfortunately, we did not have that capability yet. But other groups have successfully flown UAVs in similar situations. So we feel that it's definitely possible.
Question from Carl?
Yeah, you mentioned initially taking it up to a flight altitude of 1,000 to 1,500 feet. And of course, under 107 regs, the ceiling's 400 feet. Do you get special, like, permission from the FAA to do that as part of a fire response, or how does that work?
Yeah, we talked a lot with the stereo team about FAA regulations and what they think would be possible. And they felt that that would be within the limits as long as we're not like operating directly over human beings during that time. And if we're operating in, like, let's say we're operating right over the middle of the fire, we don't anticipate human beings being underneath us.
So is there a formal process for working with the FAA on those sort of procedural, I guess, processes?
Yeah, I'm actually unsure at the moment. It doesn't seem like the FAA has a lot of guidelines released to the public over how to handle emergencies like this. So we believe we would get special clearance. I'm not entirely sure of the process, how to receive that.
Okay, another hand for our speaker. Thanks again.